Today, we will be looking at how we implemented our setting system in our game. This is going to be a long series of videos, so stay tuned for more to come. Puzzle games, action games, FPS games, RTS games, all of these games out there share common features necessary for setting menus, with some of these games offering highly customizable settings, while others, not so much. So, how do they do this? Well, we can't know for sure, but we can replicate these features with Unity. In this video, we will cover our main setup for our settings menu, including video resolution and display mode. Again, this is just part 1 of a large series, and this part will only cover the basic setup for our project before adding more features. So, let's get started. We will start by creating a new project. It's best that we start with a new project and get things all working before implementing them into your own project. Of course, if you want to implement this inside an existing project, by all means you can do it that way. I named it Settings Tutorial, but you can name it whatever you want. We will then create an empty game object that will hold our settings menu. Rename it to something meaningful such as menus. Once created, create a canvas as a child of the game object. Now it is important to note that it is bad practice to have one mega canvas controlling all of your menus. Instead, you should have multiple canvases. That's a situation that we may come across down the line, so just keep that in mind when creating canvases. We will now set the UI scale mode under the canvas scaler component to scale with the screen size. I set the reference resolution to 1920 by 1080. It does not necessarily need to be 1920 by 1080, but you have to be consistent with these values between all of your canvases. That is because when you design anything inside these canvases, the scaling of the items will be upheld by the specified canvas resolution. That means prefabs or designs that work with one canvas may look completely different in another canvas if the resolution is not the same, so keep it consistent. We will now create a simple design for the UI. Start by adding in a title, add a text under the settings game object and anchor it to the top center. To do this, enter the presets in the Rect Transform, press and hold the Shift and Control key and choose the top center preset. Set the Y position to 0 and adjust the text accordingly. You can experiment with this, but I ended up choosing a width of 1000, a height of 200, a font of 100 with the alignment completely centered within the box. I also changed the text to just go with Settings menu. We will now add another game object under the Settings game object and rename it to Settings Tabs. We will anchor it again to the top center of the screen and set the Y position to 0. Next, we will add a horizontal layout group component and add 4 buttons under this game object. These buttons will navigate between the different settings menus that we will have, such as video settings, game settings, interface settings, and audio settings. We will adjust the Y position to align just below the settings menu title, change the child alignment to be middle center, and change the width of the settings tabs object to 1920 and the height to 100 if it has not already been done so. Now, while highlighting all the buttons, change their width and height to 300 and 120 respectively. We will now access the text object under each button and change their text to their corresponding functions and change their font sizes to 40. We will now add 2 game objects under the settings game object called left and right. This will distinguish 2 sides of the screen that will have different functionalities. The left side will have descriptions of the settings that will be implemented later, while the right side will have the list of settings that we can change. Again, anchor them to the top center of the screen, and for the right game object, we will add a panel. We will adjust the width and height to be 800 and 700 respectively. Align the page to the right by setting the Y position to -350 and the X position to 450. We will now add the UI scroll view to our panel. Now change the anchor preset to stretch vertically and horizontally. Set the right, left, top, and bottom Rect Transform to 0. Remove the horizontal scroll bar and add a UI dropdown to the content object located under the scroll view Children. We will adjust the height and width of the dropdown. You can experiment with this yourself and choose values that are appropriate. I eventually set the height to 60, width to 300, font to 30, and the arrow to 40 by 40. We will now add a text that will be aligned horizontally to our drop-down object. We will align the text to be centered in the box but aligned to the left side. Rename the text to video resolution and add however much space you want between the drop-down and the text. We will now create an empty game object and place the text and drop-down as children to the new game object. We will name it drop-down, and we will later use this as a prefab for all of our drop-down menus. Resize the width of the new drop-down game object to 800. We will add a grid layout group to our content object. Since we added this grid layout, the children of the content will automatically take on the cell size. I accidentally made it as 900, and you can visually see the game object peeking out on the right side of the scroll view. It will later be changed to 800. You can now duplicate the drop-down game object using Ctrl plus D, and you can see it filling up the scroll view. Note that the content height should encapsulate all these settings. If it doesn't, you may notice that when you run the game, the scroll view is getting cut off. An easy fix to this is just to increase the height of the content to encapsulate all the content that will be scrolled through. If we come across this problem, I will explain it in greater detail. Change the name of the drop-down to video resolution, duplicate it and rename it to display type. Change the text to match this new drop-down as well. Finally, do some adjustments with the grid layout padding and do some final adjustments with the text and drop-down positions. And there you have it. Once you have it all set up, it's time that we start scripting. Please note that this script will be slightly changed after we introduce scriptable objects and binary file saving in our next video. This is just to get a general understanding of how we will manipulate these drop-down values later down the line. Firstly, we'll create a folder to hold all of our scripts. We will then create a C# script and name it settings. Also, don't worry, I will full screen this at some point in the video. I have a tendency to work in windowed mode, so I apologize for the smaller screen. I'll be sure to fix this right at the start of the coding portions for future videos. We will delete the update function since we will not be using it. We will then create our global variables for both the drop-down objects. By adding a header text above the variables, we will essentially split up our variables into meaningful sections. It will be visible inside our editor when we add the script as a component. We will add several private variables. Store resolutions will hold all the resolutions that match with the user screen. Screen mode will hold our current display mode. For our first function, we will name it as add resolution, and this function will receive an array of resolutions. When we initially receive our resolutions at different refresh rates can be found. As a result, we get a large list of resolutions with repeating dimensions at different refresh rates. So instead, we will filter out the refresh rates based on the user's current screen refresh rate by using screen.currentResolution.refreshRate. We will add the resolutions to store resolutions and increment countRes as we enter this if statement. You will need to declare countRes as a private integer variable at the top of the script. We will now filter through the stored resolutions and add the resolutions into the resolution dimension dropdown. We will later implement the resolution to string function, which essentially just converts the resolution data into a readable string for the user. We will also surround all of our functions with region tags. This will help organize our work when we move along the series. We will now create another function called screen options. This function will receive a string that is based off of what dropdown we clicked on. If the dropdown returns the full screen string, then screen mode will be assigned the full screen mode enum. Same goes for windowed option and borderless option. After the if statement, we will set the screen's full screen mode to whatever screen mode that we stored. Create another function called resolution initialize that takes in a resolution array. This function will essentially look up all the screen resolutions that we currently have and assign the correct drop-down value that matches the resolution of the player's screen. So say the screen size that they're playing on is 1920 by 1080. The drop-down value would be at the 0th position or whatever position that 1920 by 1080 is. We will then refresh the drop-down to show the new value. We will create another function called screen initialize. This will choose the correct drop-down value based on the game's display mode. So if the screen is in full screen mode, then the value of the drop-down will correspond to the full screen mode value. Again, we will refresh the display drop-down to show the new value. The final function we will create for this video is called resolution to string. A resolution will be passed into here and it will return a string with the format demonstrated in the video. Since we are done writing these functions, we will close the region with the end region tag and minimize all of our functions. Now we get to the start function. We will first create a resolution array that stores all of the screen resolutions available for the user's screen. We will reverse it due to the resolutions being shown from least to greatest. We instantiate our store resolution array to take on the same size as the initial resolution array. We will call the screen initialize function to find out what screen mode we are using and what to assign to the display dropdown. We will then call add resolution and pass in the initial resolutions that we found. It should filter out the usable resolutions and store it in store resolution. We will then call resolution initialize to find out what resolution that the screen is currently taking on and what to assign to the resolution dropdown. Next, we have to assign on-value changed event handlers to our dropdown menus. For our screen mode dropdown, we will add a listener and call the screen option function by passing in the selected dropdown text. The order of this does matter since we hard-coded the conditions in screen option, so be careful of that. For the resolution dimension dropdown, we will immediately change the screen resolution based on what value they selected. So if they chose the second option, let's say that is 1280 by 720, then we will call the screen set resolution function and pass in the width and height of the chosen option, and in this case the second option would be corresponding to the index 1. After fixing the small error, we are finished our code. Next, we will implement this into our project, build it, and test our work. We will add the script to the settings object through the inspector. Select Add a Component and attach the settings script. Find the dropdowns under the scroll view content and attach both of the dropdowns to their appropriate variables. We also have to access the options inside our dropdowns and modify them. For the video resolution, remove all the options. For the display type, change it to full screen, windowed, and borderless. Be sure to look back at the code and check under screen options. Make sure that they completely match and that they are in the right order. We also have to access the template object under the dropdowns and change them to be slightly bigger. You'll have to enable them and adjust them accordingly. I changed the item height to 50 and the font to 25. I did the same for both the dropdown templates. You'll also need to access the template and change the scroll sensitivity to 40. This controls how fast you scroll through the dropdowns. Be sure the template is disabled before running the project. Everything seems to be in working order, so let's test this outside of the editor. Under the File tab, choose Build Settings. Press the Add Open Scenes and click Build and Run. You can save the project wherever you want. Now you can test around and see if everything is working properly. One thing that may come up is when you build your project and choose a resolution, those settings seem to be saved automatically. In other words, when you rebuild the project, you should see the exact same resolution and screen mode that you left it off at. Why is this? Well, it is because a certain registry key or index is holding the settings for you, even when you delete and rebuild your game. You would just normally delete this key and try again, however it may be dangerous to do this if you do not fully understand what you're doing. Therefore, we will be avoiding this problem altogether by loading in default settings created in a later video. You may also have noticed that some resolutions are way too small and are not necessary to have. A quick fix to this would be to only allow resolutions that have a height over 800 and a width of over 800 as well. This is not necessarily the best way to handle it, but it seems to do the job just fine. You can reduce the threshold if you would like, but I'm sure there is a better way to do this. While I hope you liked this video, I expect this series to be quite long, but each component will be thoroughly explained. In the next video, we will be going over how we can use scriptable objects and binary file generation to save these setting details. That video will be crucial for setting up the settings menu, so be ready to learn a lot. Thanks for listening, and I'll see you next time.